All right, spring semester Algebra 2 review, starting off with logarithms, rewriting between exponential and logarithmic forms. So the way this works is the base of our logarithm will be the base of our exponential equation, and then we go in a circle. So the next number I write is the 9 as my exponent, and then it equals my final piece, which is 114. Then I look for the answer choice that matches that, which is A. On number 2, we're going the opposite direction. Now I want to write it as a logarithm, and so I still start off with my base. If it's the base of my exponential function, it's also the base of my logarithm, so it's the little number down here. Then I go in a circle, so the next number, letter I write is x, and then it equals my exponent, which is 12. Then I look at my answer choices carefully because it can be confusing here if you're not paying attention. D is the right answer. Expanding logarithms, whenever we're multiplying between our logarithms, we split it up into two different logarithms where we have the first thing we're multiplying, x, plus log, and then we have the second thing we're multiplying. The other thing that we do whenever we expand is we move exponents in front of our logarithms. So the answer we're looking for is log x plus 3 log y. So that is A. Number 4 is a bit trickier in a lot of ways because we're not multiplying or dividing anything, but we do have a power going on, and we actually need to remember that the cube root of something can be written as the 1/3 power. But since it's the cube root of something that already has a 4th power, this would really be the same as x to the 4/3. So once we realize that this should be log x to the 4/3, we can take that 4/3 and move it in front. So that we get this, and then we look at our answer choices and we say, which one of these looks the closest to that, which would be C. And hopefully, if you were looking at this, if nothing else, you'd be like, well, there's a 3 here. The only one with a 3 is C, so that's got to be right, but who knows. Number 5, still expanding. This time we're dividing, so this is going to split into subtraction. So log base 8 of x squared minus log base 8 of y cubed. Then I take the exponents and I move them in front of my logarithms. So this will be 2 log 8 of x minus 3 log 8 of y, which is answer A. Use a calculator to approximate each to the nearest thousandth. So if you're on an 84 and you're doing this, you go to the math button and you scroll up and you select log base, and it gives you log and then a square and another square. You just fill in those squares. If that is not an option for you, based on whatever calculator you're using, we can do log of what's not our base, the 14, over log of our base. And that will give us the same answer. So log of 14 over log of 5, using just the regular log button on the side of your calculator. Either way, you should get C, 1.64, as your answer. Now we're going to condense some logarithms. So this is the opposite of expanding, which means these numbers in front need to become our exponents for u and v. So this is ln u to the 4th minus ln v to the 8th. Then, because it's a minus sign in between, we're going to put the u to the 4th and the v to the 8th together as division. So the first thing has to be on top of the fraction, the second thing's on bottom. So this would be A for our answer. So 8's going to work really similarly. We're going to move and make these exponents, and then it's a plus sign in between, so this is going to switch to multiplication. So this is going to be u cubed v to the 15th. When we look at our answer choices, they tried to trick us, but it's not going to work. It is B. it's okay that they put the v to the 15th first before u cubed, because multiplication you can do in any order. You can't do division either direction and have it be the same thing, but multiplication, it's the same thing either way. Number 9, we have 4 to the 2b equals 16, and this would probably be one that would be really easy to just plug the answer choices in to see which one gives us, we'd plug in for b and see what would give us 16. To actually do it the algebraic way, we would write 16 as 4 squared, and then say, aha, they've got bases of 4, which means my exponents need to be equal to each other. 2b equals 2, so I'm going to divide both sides by 2 and get b equals 1. So that's answer choice B. We're going to use a similar tactic on 10. Now the problem on 10 is that it's not obvious what numbers we can rewrite this as, because we're going to have to rewrite both of them. So hopefully you know that 36 is 6 squared, and so we're going to rewrite 36 as 6 squared and then put its exponent next to the exponent it had next to the one we're giving it. So once we realize that 36 is 6 squared, we'd want to guess and check on our calculator to see if 216 is 6 to some power as well. It is 6 to the 3rd power, and so inside of our parentheses we're going to put the exponent it already had. Now that they're both 6's, we set the exponents equal to each other, and solve this like a normal equation now. So distribute and then just multiply here, so that'll be 4k. Add the 3k over to the right, and then divide by 7. K equals -9/7. And then 11 starts some logarithmic equations, and in some ways all of these work similarly, and in other ways they're each kind of different. Like if there's a single logarithm, we want to get that logarithm by itself to start, so we divide by anything in front or add or subtract something. If there's like a +3 or something like that, we'd have to subtract it. So this gives us log base 12 of x minus 9 equals -2. I'm going to rewrite this without my logarithm. This is going to be a good strategy to remember in general, is that I can take this and say it's 12 to the -2 equals x minus 9, which is helpful because we can find 12 to the -2 on our calculator and then add 9. And if we do that on our calculator, it'll give us a decimal, but then you press math enter on the TI 80 whatever, and it tells you it's 1297 over 144, which is C. On 12, it's actually easier than the previous one, at least in some ways, because we have a logarithm on each side, and so if I have log base 8 of something equals log base 8 of something, those somethings have to be the same, otherwise it couldn't be in a true equation. And so it's like we're canceling out those logarithms and just putting what's inside of them, and now we'll solve this. The way to solve this is to get everything on one side by subtracting 5, subtracting 3n. So we get 0 equals n squared minus 4n minus 5. And then factor. And then set each part equal to 0. So this is n equals 5 and n equals -1. So that's B. You do have to be careful because these numbers, if either of them, when we plug them in for n, would give us a negative number inside of this parentheses, then that would not really be an answer. So in this case, we're fine, but it is something you have to be careful of. 13 has 2 logarithms, but they're not on either side of the equal sign. Even if I were to add the logarithm here over to the right, I'd have 2 plus a logarithm, and so that still doesn't give me the situation where I can just cross them out like I did on 12. So instead, we're going to use our condensing rules to say this is the same as log base 2 of x over x minus 1, because the minus sign changes to division. So now that I have a single logarithm, I can rearrange this as 2 to the 2 equals x over x minus 1. The way I solve this is I would write 2 squared as 4 over 1, and then cross multiply. So 4 times x minus 1, which is 4x minus 4, equals 1x. So subtract 4x over here, and get negative 4 equals negative 3x. Then divide by negative 3. The negatives cancel, giving me positive 4/3. On 14, we're going to do the same trick, but this time it's a plus sign, so they'll get multiplied together. And so that means I'm going to have x minus 4 times 10 inside of my logarithm. I'm going to rearrange this as 5 to the 3rd power equals what's inside my logarithm. And since I'm multiplying inside of here, I'm going to go ahead and distribute that and make it 10x minus 40. 5 cubed, you might need your calculator for, it's 125. And then to solve this, I need to add 40. And then I'll divide by 10. So it'll be 165 equals 10x. Divide by 10. And as a decimal, that's 16.5. Then you could change it back into a fraction using math enter, and you get 33 over 2. 15. Let's divide by the 3 that's in front because we want the logarithm to be by itself. Then we will rearrange. So this is 4 squared equals negative 4n. So this is 16, and we're going to divide by negative 4. 16 divided by negative 4 is negative 4. So our answer is A. Now, natural log of 2n minus 9 equals negative 11. First off, if they don't put parentheses, the only thing that's part of our logarithm is what's right after it. That minus 9 is not a part of the logarithm because there's not parentheses. If they'd put a parentheses right here after the negative 9, then yeah, it'd be inside of our logarithm. But they didn't, so it's not. So we need to add 9 to start off over to the other side. So that I have the natural log of 2n, but the natural log of something is the same as log with a base of e. Remember, e is a number like pi that we use in certain situations. So saying ln of 2n is the same as saying log base e of 2n. And it equals negative 2. Because I wrote it as log base e, I can rearrange this into an exponential equation. E to the negative 2 equals 2n. So I'm going to divide both sides by 2 and get e to the negative 2 over 2. Now that's not an answer choice, but hopefully you could figure out that b is the closest thing. You can actually type in e to the negative 2 over 2 on your calculator and then type in the answer choices to see which one matches up. The reason it's b is because they took the e to the negative 2 and moved it down to the bottom so that it would have a positive exponent. And since it was the only thing on top, when it moved to the bottom, we had to put a 1 on the top. On 17, this problem is like number 10 was. We have to figure out what number to write each of these as. Or actually, you could rewrite this as a logarithm and do it that way instead. if we wanted to rewrite this as 5 to some power, it'd be 5 cubed for 125. And then 625 is 5 to the 4th. And so you'd have to guess and check until you figured that out if you don't have those memorized, which you probably don't. So I'm going to distribute and then just set my exponents equal to each other. Divide by -3. And so I get -10/3 for my answer, which is A. On 18, we have an exponential equation, and so to solve this, I'm going to rewrite it as a logarithm. So this is our base, E, and then I'm going to write 88, and it equals r minus 3. So log base E of 88 is the same as the natural log of 88, which I can plug into my calculator. And after I get that, I'm going to add 3 to get rid of the -3 next to r. And when I do that, I get 7.477, which is D. But you have to make sure to close the parentheses after 88 or press enter after 88 and then add 3. Number 19, we got to move the 3 first by dividing. We can't do 3 times 10 and get 30 because the 3 doesn't have an exponent, so you can't combine those. So 10 to the r minus 5 equals 30.7. And then rearrange this into a logarithm. So this is log base 10 of 30.7 equals r minus 5. Now, log base 10 of 30 is actually the same thing as just log of 30.7. You can do it either way. You can either go to math and go up to log base, or you can just use the regular log button on your calculator. So now I need to add 5, and that gives me 6.4871, which is A. Now, finding the inverse of a function means that you switch x and y and then solve for y. So to solve this for y, I need to add 8 because I want the 2 to the y by itself first. And then I'm going to rewrite this as a logarithm. So this is going to be log with a base of 2 of x plus 8. Here's my base. Here's the next thing I write. The last thing I'm going to write is y. So x plus 8 equals y. And then I look at my answer choice and I say, aha, it's D. 21, if I'm your teacher, I told you you didn't have to do, but if you have somebody else as a teacher, then maybe they wanted you to do it. So let's see if we can figure this out. If I switch x and y, I have this. And then if I wanted to rearrange this as an exponential function, it would be 5 to the x equals this right here, 4 to the y. And then I would say, well, to get the y out of my exponent, let me rewrite this as a logarithm. But for this to work, I have to choose 4 as my base. This whole thing right here, I'm going to write inside 5 to the x, and then it equals y. So that's A. Now, I think that's kind of a particularly tricky problem, so I wouldn't expect you necessarily to figure that out on your own, but that is how you do it. And now we're done with logarithms and exponential functions, and we're moving on to rational functions. So number 22 says identify the points of discontinuity. So what you want to do is you want to plug this into y equals, and then you want to press second graph to go to your table of values, and you want to scroll through your table of values which have x's and y's, and you're looking for the places that say error. And any place that has an error is a discontinuity in your graph. And so you should see -3 and 0, which A and B are both have -3 and 0 as answers. Go figure. So either one of those would be correct. On 23 and 24, we're trying to solve. And so we want to multiply by the common denominator for all these fractions. So on 23, I have 5k, 5k, and k as my denominators. So my common denominator has to have 5k and has to have k. So I'm going to multiply everything by 5k over 1. So I'm going to distribute that to each of these fractions. And when I multiply, I'm going to have things cancel out. Like 1 over 5k times 5k over 1. Well, everything cancels out here, and it leaves us with 1. Because when everything cancels out, we still have something, so we have to put 1. So then I'm going to distribute to the next thing, 6 over 5k times 5k over 1. Well, my 5k's cancel out again. This time, though, I have 6 over 1. So this is going to equal 6. Finally, I distribute to this last fraction, so -4k plus 12 over k times 5k over 1. My k's cancel, so I'm going to have to distribute the 5, but also, and this is kind of tricky, I need to distribute the negative from in front of the fraction, and so that's going to give me -20k minus 60. Because I distribute the 5 and get 20k and 60. I distribute the negative though, both of those become negative. So now I have like terms here to add together. So this is 1 equals -54 minus 20. Okay. There we go. So I need to add 54, which will give me 55 equals -20k, and then divide by -20. So I would either need to simplify this, because both of these can be divided by 5, or I could type it into my calculator and use math enter, and I get answer choice C. On this next one, my common denominator, if I'm looking at 2n, 4n, and 4n squared, it needs to have the biggest of those numbers, which is 4, and it also needs to have the most of those n's, which is n squared. So I'm going to times each of these by 4n squared over 1, and so we'll try to do it without writing it out this time. If you need to write it out, please do. But like here, 2n will cancel with 4n squared, but it'll leave us with 2n on top. And so 1 times 2n is 2n. Here, the 4n cancels with 4n squared, but it leaves an n on top. So we do 1 times n and get n. Here, 4n squared and 4n squared, they cancel out completely, leaving us with n minus 1. And then we are left to solve this. Add like terms and get 2n equals -1. So n equals -1/2, which is C. On these two problems, we are going to type into y equals, and we are going to look at the graph for asymptotes. Vertical asymptotes are where we see the graph go up and then have kind of a break and then start down at the bottom and keep going. Whatever this vertical line is, that's a vertical asymptote. Holes don't show up on our graph. We have to look at the table of values. So you go to your table of values and look for errors. And so on this particular problem, our errors are at -1 and -2. And then we say, okay, which of those is on our graph? And so at -1, you have a really obvious break like this. At -2, nothing is happening. And so at -2, there's a hole. At -1, there's a vertical asymptote. I'm going to pull up a graph real quick-ish to show you, to make sure we're all clear on that. If you'll just hang tight for a sec. This is what your graph should look like. And so here is -2. Nothing weird is happening at my graph. It just looks like it's going to keep going up. But at -1, there is a vertical line right here that our graph is going to get really close to, but is never going to touch. And so our vertical asymptote is at -1. We have a hole at -2. So we'll do the same thing with 26. So type it in to y equals. Look at your table of values. There's errors at 2 places again. One is at +3 and one is at -3. So look at your graph. You should see your vertical asymptote is at +3. You don't see anything happening at -3, which means there is a hole at -3. So our answer is C. Our horizontal asymptotes, we actually have some rules that can help us with this. And so when we're using these rules, we compare the exponent of x on top with the exponent of x on bottom. The biggest exponent of x on top with the biggest exponent of x on bottom. We compare them. So if the top is bigger than the bottom, then that means there is no horizontal asymptote. If the top equals the bottom, then we're going to have an asymptote at y equals a number over a number. And these numbers are our leading coefficients. Coefficients is a fancy word for the numbers in front of x. So our numbers at the front are going to make a fraction and give us our horizontal asymptote. If the top is less than the bottom, then it's just y equals 0. These we can also graph, and most of the time we'll be able to tell what's going on just based off of our graph, but sometimes it can be hard to tell exactly where our horizontal asymptote is unless we use, it's usually this case right here, unless we use the leading coefficients. So let's look at this. There is not an x on top of this, which means it would be like there's an x to the 0. On the bottom, that has an exponent of 1. So that means the exponent of x on top is smaller than the exponent of x on the bottom. When the top is less than the bottom, our horizontal asymptote is at y equals 0. On 28, our exponents are both 2's. And so that means that we're going to take our leading coefficients. So the number in front of x squared, which is 1, over this number in front of x squared, which is -4. So our horizontal asymptote is at y equals -1/4. This is the case where if you're just looking at the graph, 0 and -1/4 look awfully similar. So you'd want to come back to this equation and say, okay, well, it must be the combination of 1 and -4, which is D. Finally, we have a cubed over a squared, which means the top is bigger than the bottom. And so that means there's not a horizontal asymptote at all. And if you look at this graph in particular, it's not a horizontal asymptote because a horizontal asymptote has to go straight across. In this equation, it does have an asymptote, but it's slanted. It's not a horizontal line, and that's not the same thing. So that's why there's not a horizontal asymptote. Now let's get to some multiplying and dividing and stuff with fractions. And so the biggest thing on here is that we want to factor, if possible, before we try to simplify. So here, 2x squared minus 4x has a 2x in common. And if we take out that 2x, we're left with x minus 2. On the bottom here, we're going to multiply to get 20 and add to get negative 9. So that gives us minus 5 and minus 4. We're going to times this by the other fraction, which we can't factor. So this x minus 2 and this x minus 2 cancel out, leaving us with 2x over x minus 5 times x minus 4, which is d. On 31, we want to take a look at our x's. I have an x squared and an x cubed on top, which together make x to the 5th. On bottom, I have x to the 5th. So all of those are going to cancel out. If there were more x's on top, then we'd have some x's left over to put up there. Or if there were more on bottom, we'd have x's left to put on bottom, like what B is saying. Now, we need to figure out what 13 times 18 over 10 times 4 is, which you can put in your calculator and then do math enter to get it to change back to a fraction. Or you can say, well, 18 is divisible by 2, and so is either 10 or 4, whichever one you want to use. So this gives us 20 on bottom, which means it has to be 117 on top because it's D. 32. When we divide, we have to flip the second fraction before we start canceling things out. So we have an a on bottom and two a's on top because that's what a squared is, which means we're going to be left with a on top. Then we're going to have to do 11 times 10 over 14 times 5. Well, the 10 and the 5 can cancel and leave us with a 2 on top. The 2 and the 14 can cancel and leave us with a 7 on bottom. So this is 11 over 7 with an a on top. On 33, we need to factor the top of the first fraction. What multiplies to get 50 and adds to get 15 would be 5 and 10. Then we need to flip the second fraction so that now the 10 is on top. And I'm going to factor 10k plus 50 because they have a 10 in common. So this is going to give me the 10's canceling out and the k plus 5's canceling out. So k plus 10 over 5 is left over, and my answer is B. When I add or subtract, I have to have common denominators. 34 already has common denominators. They're both 24x. So I'm going to add these x's together and get 3x. The y doesn't have anything to add with, so it's going to stay negative 3y. It's over 24x. And then I look at my answer choices and I go, oh, that's not an answer choice. There must be something else I can do, which because all of these are divisible by 3, I can simplify. If only 2 of them were divisible by 3, it wouldn't work. I have to have all the numbers being divisible by the same thing. So that gives me 1x minus 1y over 8x, which is A. On 35, I need to get common denominators, and my common denominator is going to be a combination of the two denominators I already have, 3 times x plus 3. That means I need to multiply the first fraction by what it's missing, which is 3. I need to multiply the second fraction by what it's missing, which is x plus 3. So on top of this, I'm going to have 3 times 3, which is 9, and then I'm going to distribute 4x into my parentheses and get 4x squared plus 12x And so that gives me D. Then I need to scroll down. So we're subtracting here. Our common denominator has to have m minus 5 and m minus 3. And so this would be a slightly risky guess, but you might be like, oh, well, I already know it's C because of that. But sometimes we can simplify. So like I said, it's kind of risky to just circle that as the right answer without doing anything else to try to check it. So if I actually want common denominators, I multiply the first fraction by m minus 3 and the second one by m minus 5. And then I'm going to distribute. So this will be 3m squared minus 9m. This has to distribute with the negative. So negative 6m squared plus 30m. I've got some like terms here. So the m squareds add together and the m's add together. And so that does confirm that C is my answer. That leaves us off, oh, nope, one more. We got to simplify this and then we'll be done with rational expressions. So I need to factor the bottom. They have a 5a in common. So I take that out and get a plus 2 left over. The a plus 2's cancel. The trick here is that if I cancel everything off the top, I put 1 on top. 5a has to stay on the bottom. So that's B. Now we're on to conic sections. So if it's y equals a negative, that opens down. My vertex is positive 2, comma, negative 9. Because remember, when we're inside parentheses, we change the sign. When we're outside parentheses, we don't. So this is B because of the vertex and the way it opens. If it's x equals a negative, it opens to the left. This is telling me my y value because it's in here with y, positive 8. This is telling me my x value is 3. So left and 3 comma 8, which is B. Now these next ones that are conic sections, it's one of those things that these are all really similar. We want the center point, which is on this one, negative 2 comma 0. And when we put it into and look for which one of these is right, we change the signs. So that means this is x plus 2 and then y plus or minus 0, doesn't really matter. But our answer here is A. The other part to this is the radius, which is 4. We square it and get 16, so there's no way it could have been B because they didn't put 16. So A is our answer. 41, they gave us the center, 3, negative 7. So when it goes in parentheses, it changes signs. So it has to be B. And then the radius is 3 squared, which is 9, which is what's over on the right side. 42, the center here is not there. It is right here at 2 comma negative 4. So we can look for that. It should be x minus 2 and y plus 4, which means C and D are incorrect. The numbers on bottom here tell us how much we went left and right and up and down. I'm going left and right 5. That should be under x. So 5 squared is 25, and our answer is A. 43 is a hyperbola. The center is at negative 1 comma 1. So we look and see, for one thing, since it's on the left and the right side, y is not first, so it can't be B. And then it can't be D because they didn't change the sign of the first one. It's supposed to be x plus 1 and y minus 1. And then we say, okay, how much am I going left and right and up and down? Going left and right 4. So under x should be 4 squared, which is 16. (44) Our vertex is at 4 comma -6. And it opens up, which means that we have y equals a positive number. So actually, we only needed one of those pieces of information, either the vertex or which way it opens. In this case, it just so happens, because if it had opened down, we would have only narrowed it down by 1 instead of kicking all of them out. The 1/3 in front has to do with how quickly this goes up. Whenever I've gone to the right 1, I've only gone 1/3 of the way up to the next number. So, in case you were wondering. 45, my vertex is at -5, -1. And it's x equals, because it opens to the right, and since it opens to the right, it should be positive in front. So the -1 goes in with y, and then the -5 is on the outside. The -1 changes signs. So the difference between having a 1 here and a 2 here is how fast it's going to the right. And so I should be going up 1 and over 1, which is a. If I was going up 1 and then over 2, that's what having a 2 in front would look like. You could always plug in numbers to try to figure out which one is right if you needed to. Probability. Our situation is up here in the instructions. 2 red, 4 blue, 6 green, for a total of 12 marbles. The probability of choosing a red marble. There are 2 red marbles out of 12, so that's 2 out of 12, which is 1/6. The probability of choosing a red or a blue. Well, there are 2 red and 4 blue for a total of 6 out of 12, which simplifies to be 1/2. This is where it gets trickier because we're trying to draw 2 marbles in a row. So 48 asks us to choose a blue marble followed by a green marble with replacement. What that means is I'm going to try to pick a blue marble, which is 4 out of 12. And then I'm going to put the marble back in so that I still have my original setup. I'm going to pick and I want to pick a green marble, which has a probability of 6 out of 12. And then I'm going to multiply them together and simplify, and that gives me 1/6. So with replacement means that both of these will have 12 as the denominator because we took out a marble but then we put it back in. For 49, we want to take out a green marble, which is 6 out of 12, but then we want to take out a red marble, and this is without replacement. So we take out the green marble, we don't put it back, and we take out a red marble. And so there's 2 red marbles, but now there's only 11 to pick from. So we simplify this and we get our answer, which is D. This is going to require us to use our unit circle. And so I have a unit circle to show you. And so the way we use this is we go to whatever our angle is they listed. For cosine, we look at our x value. For sine, we look at our y value. And for tangent, we do y over x. So let's take a look at our problem. Sine of 330. At 330, sine, our y value, is -1/2. So our answer is B. Cosine of 315 is the x value at 315. So at 315, my x value is square root of 2 over 2. Tangent of 45. Tangent is our y value over our x value. So that means we need all of what's on the point. 45, square root of 2 over 2 over square root of 2 over 2. Well, those are the exact same thing, and so they're going to cancel each other out and leave us with 1. And then finally, cosine of 5 pi over 3. So our x value at 5 pi over 3 is 1/2, which is D. 54 and 55, we're going to use sine, cosine, and tangent. And we're going to take what they gave us, cosine of theta, it's adjacent over hypotenuse. Remember, so, ka, toa. So, we're going to draw just a generic right triangle. Here's our right angle. Here's our angle theta. The adjacent side is the one connected to theta. The hypotenuse is the one across from our right angle. To find sine, we would need our opposite side, which we can find with the Pythagorean Theorem. If we do the Pythagorean Theorem, we get that this side would be 7. Sine is opposite over hypotenuse, so it's 7 over 25, which is B. And then 55 is going to work out very similarly. So sine is opposite over hypotenuse, so that's 5 and that's 13. Pythagorean Theorem to figure out the third side will give us, we have to do 13 squared minus 5 squared and then square root, which gives us 12. So cosine is adjacent over hypotenuse, which is 12 over 13, which is D. Now we're given a point, and so negative square root of 15, comma 7, we have to go left square root of 15 and up 7. This is a right triangle, and the angle always is the one next to 0, 0. So we want cosine, which means we need adjacent over hypotenuse. So to find the hypotenuse, we would do 7 squared plus square root of 15 squared equals c squared. When you do the Pythagorean Theorem, you never need to put the negative in because the negative should get squared away. And so putting the negative in just makes you more likely to screw up. If you do this, c is 8. So adjacent over hypotenuse is negative square root of 15 over 8. Same kind of deal on 57. Now we're going to go right square root of 5 and down to, so here's theta, here's right angle. We would Pythagorean Theorem to find the hypotenuse because we want sine. So c is 3. So opposite over hypotenuse is negative 2 over 3, which is b. Now 58 and 59, in my class we didn't do any problems like this, so just keep that in mind. If you're in my class, we kind of basically said, don't worry about it. Tangent theta equals negative 1 is asking us at what angles would we get a y value over an x value to equal negative 1. The only way for that to happen is to look for places where the two numbers would cancel out, like square root of 2 over square root of 2. But if they're both positive, then that would cancel and give us a positive, and we want to get a negative 1. So that would happen at 135 and at 315. So that is our answer to this, D, 135 and 315. 59 is easier because sine is our y value, so we're looking for the angles where our y value is negative square root of 3 over 2. So let's take a look at our unit circle. Our y values are positive here, negative here. So at 240 and at 300, which is D, those are the two places where our y value is negative square root of 3 over 2. To convert from degrees to radians, we put this over 1 and then multiply by pi over 180. So we do on our calculator 525 over 180, and we simplify that, and then we're basically putting a pi on top after we simplify. So that's going to give us C. Here we're going to do 180 over pi because we want the pi's to cancel. So then we'll type in our calculator 8 times 180 divided by 9 and get 160, which is B. We're trying to find theta, and so we look at what sides they gave us. Here we have opposite and hypotenuse. So we're going to say sine of our angle theta equals 5.9 over 10.9. To solve for theta, we go on the calculator and press second sign, which gives us the sine -1 button thing. And then type in 5.9 divided by 10.9. Make sure you're in degree mode for this. Our answer is 32.8, which is A. On 63, from this angle, 8 is opposite and 5 is adjacent. So we're going to use tangent. And our opposite side is over our adjacent side. So I do second tangent of 8 over 5. Again in degree mode, and I get 58 degrees. (64) Here's my angle. X is my hypotenuse. 1.3 is adjacent. So I'm going to use cosine of my angle equals adjacent over hypotenuse, and then I'm going to solve for x. To solve for x, I multiply both sides by the bottom of my fraction and get x cosine 72 equals 1.3, and then I need to get x by itself, so I divide by this cosine 72. So x equals 1.3 divided by cosine of 72, which is 4.2. When you do that, make sure the 1.3 is first, divided by cosine of 72, and not the other way around. Here we have the adjacent side to 20 degrees and the opposite side to, oh, that was one too many p's there, so just pretend that didn't happen. Oh, look, it's an O, which is the next letter in opposite. Anyway, that's tangent of 20 equals x over 9. So we're going to multiply both sides by 9. And so that will leave us with x. We just need to do 9 times tangent 20 degrees. Make sure that you either write the 9 first or plug in the 9 first or put the 20 in parentheses. Don't do 20 times 9 and then do tangent. That's not the same thing. The correct answer here is A, 3.3. Now, positive and negative coterminal angles we get by adding and subtracting 360 degrees. If I do 235 plus 360, I get 595. If I do 235 minus 360, I get negative 125. So C is my answer. Now, that works out well as long as our number that we start off with is between negative 360 and positive 360. But 570 is bigger than 360, so this is going to have to work a little differently. If I add 360, then I get a number that is bigger than all of my answer choices. So instead, I'm going to start off by subtracting 360, which gives me 210. And that is actually enough information on this to give me A. But the way we get the negative 150 is by subtracting 360 again. So that gives me the negative coterminal angle that I wanted. Word problems. A ladder is leaning up against a building because that's what ladders do. That ladder is 9 feet long. I don't know why I wrote theta there because we actually know that that angle between the ladder and the ground is 53 degrees. We want to know how high up the building the ladder goes. The building is taller than what the ladder reaches up to, so we want to see how high up it got. This gives us an opposite, hypotenuse, situation. So we're going to do sine of 53 degrees equals x over 9. So we need to multiply by 9 to solve for x. So x equals 7 feet. A 525-foot tall building casts a shadow of 265 feet. What is the angle of elevation to the sun? So our building is straight up and down. Our shadow, well, the building shadow, or any shadow, is along the ground. And so it doesn't make any sense for our hypotenuse to be 265 because that's not where our shadow is. And also, our hypotenuse can't be bigger than one of the sides of our triangle. The angle of elevation to the sun, what's happening is the sun is up here, causing there to be a shadow, and so we want to know this angle that is up to the elevation to see the sun, like if there was a person laying on the ground here, like looking up at the sun. Never mind. So this is opposite and adjacent, and that means we're going to use tangent of theta equals 525 over 265. So that's second tan, which gives us the tan negative 1 thing, 525 over 265, which is 63.2. And finally, the moment we've all been waiting for, sequences in series. Our formulas are in our problem, and the only thing we may have to remember is that when it says a of 21, that means n is 21. I'm going to plug into this formula right here, which I just marked through, so let me make that go away. A of 21 equals A1 plus 21 minus 1 times D, which is negative 200. So that gives me, if I plug it into my calculator, an answer of negative 4036. 71. N is 9. I'm going to plug into this formula. So A of 9 equals A1, which is negative 1, R, which is negative 5, N minus 1, so 9 minus 1. Make sure that you put the negative 5 in parentheses. The negative 1 doesn't really have to be, but this needs to be negative 5 in parentheses, and outside the parentheses you need to have the exponent. Otherwise, on this one, all it does is change whether you get a positive or a negative, which you still hopefully would have guessed D even if you'd gotten positive, but in a different situation it could be a lot more terribly wrong if you do it wrong. Never mind. So fill in all of our things into our formula. And then we get, and when we plug this in our calculator, we get D, 2625. Then we're going to evaluate this geometric series. So S of 8 equals 4 minus 4 times negative 2 to the 8 over 1 minus negative 2. Again, this needs to be in parentheses. Our answer on this will be negative 340. So that's it. That's the spring semester Algebra 2 review.